Sum number 6. Prove that tan theta minus cot theta is equal to 2 sin square theta minus 1 upon sin theta into cos theta. I am asked to prove this identity. Then I am asked to prove this. I think we have done. Second is prove that 7th tan square A minus tan square B is equal to sin square A minus sin square B upon cos square A into cos square B. And another answer is cos square B minus cos square A upon cos square B into cos square A. Now let us try this. See, I have to start with the LHS here, because my LHS is made up of tan and cot and RHS is made up of sin and cos. So I can convert tan and cot very easily in terms of sin and cos. For tan, by definition you put sin by cos, and for cot you put by definition cos theta by sin theta. Clear? So my answer is LCM is sin into cos. That we got it. My RHS also required sin theta into cos theta in denominator. So 50% job is over. If you do cross multiplication, it is sin square theta minus cos square theta. Sin into sin square. But if you look at the RHS, my RHS is made up of only sin. So I have to say goodbye to cos square. So cos square can be avoided by just putting 1 minus sin square in place of cos square. Now see, sin square minus 1, minus plus sin square. So sin square plus sin square is 2 sin square theta minus 1 upon sin into cos. And that is your RHS. I start with LHS and come to RHS. Here I will start with number 1 and come to number 2. Then I start with number 1 and come to number 3. So by 1 and 2, capital 1 is capital 2 is capital 3, or by 1 and 2, LHS is RHS. 2 RHS. Tan square A minus tan square B. This is your LHS. Number 1. I want to convert everything in terms of sin and cos. So I have to apply the definition of tan square A is sin square A by cos square A minus sin square B by cos square B. LCM is cos square A into cos square B. Do cross multiplication, you will get sin square A into cos square B minus cos square A into sin square B. Clear? Now, look at the first RHS. I want sin square A minus sin square B. Denominator, I got it. Denominator of both RHS is cos square A into cos square B. So that we are getting it. So I have to change my numerator. Numerator में I want sin square A. So I try to protect sin square A. And in place of cos square B, I want to avoid cos square B. So I put cos square B की जगह 1 minus sin square B. Now second time I want sin square B. So minus sin square B I try to protect. For cos square B I put 1 minus sin square. Cos square A into cos square B. Now you just open it by applying distributive law. Sin square A into 1 sin square A minus sin square A into sin square B minus sin square b, minus minus plus sin square a into sin square b. So like term with plus minus go away. Denominator is cos square a into cos square b. So I got my answer sin square a minus sin square b upon cos square a into cos square b. So I start with 1 and come to number 2. Give number 1 to this. Now in order to get number 3, up to this step my proof is common. I start with 1 and 1 should be written as this. Sin square a cos square b, right, minus cos square a sin square b, right, upon cos square a cos square b. This is my second step of number 1. First step is this, second step is this. Now look at the RHS number 2. I want cos square b. So I try to protect cos square b, and in place of sin square a, I put 1 minus cos square a. The things which you want, you take it out, and things which you don't want, you do something with that particular term. Now I want cos square a. So I protect cos square a, and for sin square b I put 1 minus cos square b. Clear? According to requirement of RHS we should work, and that we are doing. What I want, that I keep as it is, and what I don't want, uske liye I put substitution by using identity number 1. When I open it, it is cos square b into 1 is cos square b, minus cos square a into cos square b, right, minus cos square a, minus minus plus cos square a into cos square b. Clear? So we'll go away, like term with opposite sign, and denominator is cos square a cos square b. So you got your answer, cos square b minus cos square a upon cos square a into cos square b. This is your number 3. Give number 2. So by 1 and 2, what can you say? Capital 1 is, capital 2 is, capital 3. Clear? Clear? So when you are given 3 sides, don't worry. Prove any 2 identity. Give number 1, number 2, or you simplified all 3 sides and get same answer. So by 1 and 2 we can say capital 1 is, capital 2 is, capital 3. Now we are giving another 2 sum. 6 and 7. Now I am giving 8 and 9. Okay. 8 sum is very similar to that. Little bit different. Prove that sin theta plus sec theta. We have done in previous lecture sin theta plus cosec theta whole square, and where sin and cosec are reciprocal of each other, but here sin and sec are not reciprocal. ध्यान रखना. Cos plus cosec whole square is equal to 1 plus sec plus cosec whole square. Okay. Another sum is very difficult sum and very important sum. Sum is 9. Prove that लंबा सम है 1 upon sec square theta minus cos square theta plus 1 upon cosec square theta minus sin square theta. Bracket complete. Sin square theta into cos square theta is 1 minus sin square theta into cos square theta upon 2 minus 2 plus sin square theta into cos square theta. First sum is, you write in place of sec 1 by cos, definition and write in place of cosec 1 by sine. Then you just open the bracket, open the square. Then you make a pair of 2, sine square with cos square, 1 by cos square with 1 by sine square, and sine by cos with cos by sine. And then you simplified, you are going to get the expected answer. See, process I said, LHS. Sine plus 1 by cos whole square, clear? Here cos plus 1 by sine whole square. Open the square. It is sine square plus 2 times sine by cos, clear? Plus 1 by cos square, clear? Here it is cos square plus 2 times cos by sine plus 1 by sine square, clear? Now, you make a pair of 2. This sum you are supposed to complete. I just give hint. Sine square plus cos square की pair बना दो. फिर 1 by cos square plus 1 by sine square की pair. So it is sine square plus cos square by sine square into cos square, okay? And third pair is 2 times sine by cos plus cos by sine. So 2 times sine square plus cos square upon sine cos, okay? Now I think sum is very simple. See, this is 1. This is 1 by sine square cos square, so cos x square into sec square. And this is 2 times 1 by sine into cos. So 2 times cosec into sec. You got the perfect square or not? This is, the answer is 1 plus cosec square into sec square plus 2 times cosec into sec. You clear? This is 1. This is 1 upon sine square cos square. So this. And this is 2 into 1 upon sine cos. So this. And it is nothing but the perfect square of 1 plus cosec into sec. Clear? And that is your RHS, clear? Clear? So these 3 steps of sum number 8. Continue, okay? This sum is very tough. LHS is very complicated. I start with LHS. 1 upon sec square is 1 by cos square. You write by your own LHS. I am writing the next step. You have to write down LHS, okay? Plus 1 by sine square, 1 by sine square, minus sine square, clear? Bracket complete. Outside sine square into cos square. This is my first step, okay? What is my second step? After cross multiplication of these two, cos square will come up. It is cos square upon 1 minus cos raised to 4, clear? Here it is sine square upon 1 minus sine raised to 4, clear? Bracket complete. Second step, outside sine square into cos square. Are you clear with second step? Now third step. For 1 minus cos raised to 4 and 1 minus sine raised to 4, I can factorize. 1 minus cos square is sine square, right? And another factor is 1 plus cos square. Similarly, here sine square, 1 minus sine square is cos square into 1 plus sine square, clear? Bracket complete. Outside cos square into sine square, clear? Now fourth step. Fourth step में I will take LCM. sine square into cos square into 1 plus cos square into 1 plus sine square, and then I do cross multiply. What is the answer? See, LCM in your denominator is sine square theta into cos square theta into 1 plus sine square into 1 plus cos square. Clear? And if you do cross multiplication, just first term is cos square into 1 plus sine square. So it is cos raised to 4 into 1 plus sine square. And here sine raised to 4 into 1 plus cos square. Outside sine square into cos square. This is my 4th step. This sum is of 7 steps. I told you few sums require more than 6-7 steps. But most of the sum we have done by minimum 3 or maximum 5 steps. So what is sine square cos square? Sine square cos square cancel. Okay. Now denominator I got it. What denominator for RHS you required, that I got it. See, if I multiplied 1 plus sine square into 1 plus cos square, then it is 1 plus sine square plus cos square plus sine square into cos square, right? And that is my 2 plus sine square into cos square, because this is going to become 1. So denominator to aa gaya. For numerator, I make a pair of cos raised to 4 theta into 1 plus sine raised to 4 theta into 1. This I have taken in one bracket. And another bracket, cos raised to 4 sine square plus sine raised to 4 cos square. So I take out sine square cos square common. In bracket I will get 1 plus sine square theta plus cos square theta. Clear? Are you clear with this? Step number 5. Right? For cos raised to 4 plus sine raised to 4, if I consider cos square as A and sine square is B, then it is A square plus B square, okay? And A square plus B square का formula है A plus B whole square minus 2AB, okay? Plus A plus B is 1. Because A I have considered as cos square and B I have considered as sine square. Then A plus B is 1. So here I can apply direct formula. Cos raised to 4 plus sine raised to 4 is 1 minus 2 sine square cos square. The reason is here, because, okay, and plus sine square cos square into 1. I got it. Denominator is 2 plus sine square into cos square. And numerator is 1 minus 2 sine square cos square plus sine square cos square. So, like term it is 1 minus sine square cos square upon 2 plus sine square cos square. That is your RHS. Now count the number of steps. 1, 2 and 3 steps we have already performed. This is 4, 5, 6 and 7. Not more than 7. Within 7 steps we have done such a big sum. Okay. But your application should be appropriate. And whatever you are, any step you are writing directly, you must write down the reason beside the steps. Otherwise, how this cos raised to 4 plus sine raised to 4 is 1 minus 2 sine square cos square, that you must explain to the examiner that I have not written this formula directly. I derived it and then I have written. Okay. Now see, छोटी सी जगह है, one small sum I am giving you. See, sum is simple sum number 10. If sec 3 beta, we have done for cosec in your textbook, is equal to cosec beta minus 22 degree. And 3 beta is acute. find beta. This is the small questions. Space is less, so I have taken this small sum. Now we have learned, here we apply knowledge of our complementary angle. Sec something is equal to cosec something. Sec and cosec are equal if and only if the angle are complementary. Sec theta, sec alpha is cosec beta if alpha plus beta is pi by 2, matlab 90. So 3 beta plus beta minus 22 degree is 90 degree. This is the relation I got it from my knowledge of complementary angle. Sec and cosec will make a pair, tan and cot will make a pair, sin and cos will make a pair. Sec is equal to cosec matlab the both angle are complementary. Sum of both angle is 90. So my 4 beta will be 90 plus 22. So 112. So my beta will be 112 degree upon 4. So it is 4 2 ja 8 and 4 8 ja. Beta is 28 degree. So naturally your 3 beta is going to remain an acute angle. Right? It is 84. And 84 is an acute angle. Clear? Now 11th sum. See, one sum I am giving you. I show you that in that sum you don't require to convert the sum in terms of sin and cos. Without converting the sum in terms of sin and cos, we are going to get the answer. Okay? Look here. Sum is prove that 1 plus sec square A into cot square B upon 1 plus it is tan square 1 cos square 1 plus tan square A into cos square B, and here sec square C into cot square B. Answer is 1 plus tan square C into cos square B. Look at this sum. I want to prove LHS is equal to RHS. So I start with LHS. See, I show you, I want to show you that without converting in terms of sin and cos, also we can do the sum. It depends on the requirement of RHS. My RHS does not want any sin or cos. So I need not to convert or express my LHS in terms of sin and cos. Dhyan rakhna, it's a special sum. And here you will realize that according to requirement of RHS we should work. If you don't work according to the requirement, we may get some solution is too big. Here within 3 steps we will get the answer. Sum looks very difficult, okay? But it is not difficult. See, I look at the LHS. Now I look at the RHS. RHS want in place of sec square A, tan square A. So that gives me idea of putting sec square A is, I use the identity 1 plus tan square A, okay? Because RHS require tan square A. So I converted sec square A in terms of tan square A, and that is only possible if I applied second identity. But in place of cot square B, I want cos square B. So here it is not advisable to use identity. Here it is advisable to apply definition of cot. Definition of cot square B is cos square B by sin square B. Dekha? At one place I applied identity, another place I applied definition, because that is a demand of RHS. Same way, for sec square B I write 1 plus tan square B, but for cot square B I won't write cosec square B minus 1, because that is not requirement of my RHS. For cot square b, I write cos square b by sin square b. This is my first step, okay? Now my second step is do cross multiplication. 1 is multiplied with sin square b. So it is sin square b plus 1 plus tan square a into cos square b. I don't write down denominator cos square b because that is a common denominator for both n and d. So only by cross multiplication you will get this answer, okay? Tan square b into cos square b. Clear? Tan square c. Tan square c, sorry. Here is c. Okay? Clear? Clear? Now, that sin square b go away. Now if open it, it is sin square b plus cos square b plus tan square a into cos square b. Got it? Upon sin square b plus cos square b plus tan square c into cos square b. Clear? Sin square b plus cos square b is 1. So I got the RHS within 3 steps. See? Here I adopt that principle. Okay, when we start with LHS, constantly we keep in our mind what we require for RHS. And according to requirement of RHS, we have to select the formula. Whether I should apply identity or I should apply definition. That decision we will make looking to the RHS. ऐसे ही दिल हो गया तो हमने यूज कर दिया, not like that. You should keep in your mind what you require for RHS. Otherwise, instead of 1, 2, 3 and 4 steps, you may have 15 steps. Clear? So if you want to apply short and sweet method, then you should keep in your mind what I said. Sum number 11, okay? Now 12. Let us try other sum. Sum is 12. Prove that tan theta upon sin cube theta upon cos theta plus sin theta into cos theta is equal to 1. Numerator is tan theta. Denominator is sin cube by cos plus sin into cos. And answer should be 1. 13 sum. This I think we have done. Is prove that under root sec minus 1 upon sec plus 1 plus under root sec theta plus 1 upon sec theta minus 1 is equal to 2 cosec theta. Then sum number 14 is prove that this also we have done. Sec theta minus tan theta whole square is 1 minus sin upon 1 plus sin. Let us try. I start with LHS because LHS is more complicated. My answer on RHS is 1, so I want to avoid every function. Let us take tan theta is sin by cos because I want to remove everything. I want to eliminate everything. Here I will take sin cube theta plus cross multiplication is sin into cos square theta upon cos theta. Clear? cos theta will go out. What is left? Sin theta upon, here you take out sin theta common, in bracket you will get sin square theta plus cos square theta. So it is sin theta upon sin theta, because sin square plus cos square is 1, and that is 1, and that is RHS. How many steps? 1, LHS लिखोगे तो 1, 2 and 3, 4. 4 step में 2 steps are of LHS and RHS, so only 2-3 steps. Here I start with LHS, 14 sum, sec minus 10 whole square. For sec I write 1 by cos, and for 10 I write sin by cos. Clear? Because here also I want to get my answer in terms of sin. So it is denominator LCM is cos theta, it is 1 minus sin theta. I think this type of sum we have done. It was given in textbook. It is 1 minus sin theta whole square upon cos square theta. For cos square theta I will write 1 minus sin square theta. 1 minus sin square has 2 factors. 1 minus sin theta whole square is 1 minus sin into 1 minus sin. But 1 minus sin square is 1 minus sin into 1 plus sin. I think we have done with cos. There. What is my answer? 1 minus sin upon 1 plus sin, and that is RHS. Clear? Clear? For this sum, I have to rationalize. When I start with LHS, I will rationalize both n and d by sec minus 1. So my first step, I bunk these steps now. I give you hint only. You complete it. Because this type of sum I did before. Rationalize with sec minus 1 तो ऊपर हो जाएगा sec minus 1 whole square, और नीचे हो जाएगा sec square minus 1, so tan square. When I rationalize with sec plus 1, ये हो जाएगा sec plus 1 whole square. Clear? होल स्क्वायर अंडर रूट के अंदर, एंड नीचे आएगा सेक स्क्वायर माइनस 1, सो टेन स्क्वायर. गॉट द आंसर. व्हाट इज इट? सेक माइनस 1 बाय 10. एंड व्हाट इज दिस आंसर? सेक प्लस 1 बाय 10. सेम डिनोमिनेटर, एट द न्यूमरेटर. सेक माइनस 1 प्लस सेक प्लस 1, सो 2 सेक थीटा. 2 सेक थीटा अपॉन टेन थीटा. 2 sec theta upon tan theta, and sec upon tan theta is what? Cos sec theta. Will you able to manage? See, it is not clearly written. Should I rub this and write it again? We write it as plus under root sec plus 1 whole square upon 10. Clear? Plus under root sec plus 1 whole square upon 10. Clear? So it is sec minus 1 upon 10 plus sec plus 1 upon 10. So it is 2 sec theta upon 10 and 2 sec theta upon 10. Sec is 1 by cos and 10 is sin by cos. Cos cos gaya, 1 by sin is cos sec. So that way we complete 12, 13 and 14. Clear? Sum is so that tan cube theta upon 1 plus tan square theta, right? Plus cot cube theta upon 1 plus cot square theta is equal to sec into cosec minus 2 times sin into cos. Matlab I want to get everything in terms of sin and cos. So I start with LHS. For tan cube I write sin cube by cos cube, right? You write down LHS first, huh? I don't write. 1 plus tan square is sec square. Here cot cube is cos cube by sin cube. And for 1 plus cot square you write cosec square. So it is 1 by sec square is 1 by cos square. So it is sin cube upon cos cube, and sec square will come up as cos square. Here cos cube by sin cube and cosec square come up as sin square. So it is cos square and cos cube cos, sin square and sin cube sin. So it is sin cube theta by cos plus cos cube theta by sin. If you simplify it is sin raised to 4 plus cos raised to 4 upon sin into cos. Clear? Yeah, but it's very simple, going very smoothly. Now I want to get my answer simply sin cos and 1 by sin cos. So sin raised to 4 plus cos raised to 4. If I take A is sin square, B is cos square, just now I explained, then sin raised to 4 plus cos raised to 4 can be written as sin square plus cos square whole square minus 2 sin square cos square. So it is 1 minus 2 sin square cos square. Why? Because A plus A square plus B square is A plus B whole square minus 2AB. But A plus B is 1. So I can write directly here 1 minus 2 sin square cos square upon sin cos, right? You have to write down the region. Because if A is sin square, B is cos square, then A square plus B square is A plus B whole square minus 2AB, but A plus B is 1. So that way you write the region. Now separate it out. 1 upon sin cos minus 2 sin square cos square by sin cos. So only 2 sin cos. Because 1 sin 1 cos will go away. Clear? Clear? 1 upon sin and 1 upon cos is cosec into sec minus 2 sin into cos. You got your RHS? Yes. So identity are not that difficult. Okay. Now 17 sum. 16. See, it is given as if sin theta 1 minus theta 2, this type of also sum is given in your textbook, and cos theta 1 plus theta 2 is 1/2. Find theta 1 and theta 2, and you are given theta 1 is less than theta 2 and theta 1 plus theta 2 lying between 0 to 90, that is given to you. You try this. And another sum is 17 if tan theta is 20 by 21. Find 1 minus sin theta plus cos theta upon 1 plus sin theta plus cos theta. Or they can ask you, prove that this is equal to 3 by 7. That way also they can give you. Instead of find, they can give you, prove that answer of this is 3 by 7, like that. Now sin theta, sin something is 1/2. Sin is 1/2 at sin 30 degree. Clear? You know very well. Sin theta 1 minus theta 2 is sin 30 degree. So I get this relation, theta 1 minus theta 2 is 30 degree, okay? Cos theta 1 plus cos theta 2 is 1/2, so it is cos 60. So my theta 1 plus theta 2 is coming as 60. Clear? Solving these two, I will get 2 theta 1 is 90 degree. So theta 1 is 45 degree, okay? Right? Now if theta 1 is 45 degree and theta 1 plus theta 2 is 60 degree, so naturally my theta 2 is 60 minus 45. So it is 15 degree. But here they say theta 1 less than theta 2. Here they have given theta 1 less than theta 2. Right? The condition given is theta 1 less than theta 2. And here I am getting theta 1 greater than theta 2. What to do now? Tell me what to do. Is there any mistake they have made? You agreed with me that they have made some mistake? Or you don't agree with me? Here my theta 1 is coming because sin is 1/2. Right? Right? Cos is also 1/2. Sin is 1/2 at 30 degree. Right? Cos is 1/2 at 60 degree. So theta 1 minus theta 2 I am getting 30. Theta 1 plus theta 2 I am getting 60. So when you add them, I will get 2 theta 1 is 90. So my theta 1 is greater than. So they must give theta 1 greater than theta 2. It was a printing mistake. So when you refer any sum from any book, blindly don't put faith on answer or on given condition. Okay? If you are perfectly right, then you should have no doubt about your answer. So sometimes answer can be wrong also. Okay? So why? I know it was wrong, but I have written specially to show you कि देखो थीटा 1 लेस देन थीटा 2 दिया है तो, और आपका थीटा 1 ग्रेटर देन थीटा 1 आ जाए तो डरना मत. It is a printing mistake, nothing else. Now tan theta is 20 by 21. If I draw a triangle and this angle will be considered as theta, then this is my ABC. My AB will be 20K and my BC will be 21K, because definition of tan theta is opposite side upon adjacent side. So by concept of triplet, it is 400 plus 441, 841, right? And 841 is a square root of what? Yes, come on, try. You know, this is AC square is 841K square. So 841 का स्क्वायर रूट आपको आना चाहिए. प्राइमरी लेवल याद करो. 2 2 जा 4, राइट, माइनस 441, 2 and 2 4, 49, 9 जा, right? So what is this 29K? ऐसे भी you remember your triplet orally. 20 21 तो 29, 5 12 तो 13. You should remember some of the triplet, right? There are many triplets which you remember orally, so that you need not to do all this work. You can save your time. So now I put the value of sin theta. Sin theta is opposite side upon hypotenuse. So 20 by 29. Cos theta is adjacent upon hypotenuse. So 21 by 29. 1 plus 20 by 29 plus 21 by 29. Your answer is 3 by 7, okay? Let us do it. LCM is 29, both N and D. So don't write 29 minus 20 plus 21 upon 29 plus 20 plus 21. So what is the answer? This is 29 plus 21 is 50 minus 20. 30, and here 50 minus 20, 70. So answer is 3 by 7. Clear? Clear? Now next sum. 18. This is the last lecture of Trigo. Now you have to do practice from reference book and textbook again. And then keep your doubts ready. And I don't think you will be having any doubts now. We have done enough practice. And I don't think you will be having any problem. If 16 cot A is equal to 12, find the value of sin A plus cos A upon sin A minus cos A. I want to give you few sums of conditional identity. Suppose some condition is given, and by making use of that condition, you are asked to prove some identity. Beside fundamental identity, you are given some condition, and by making use of that condition, you have to prove some other identity. That type of sum are not given in your textbook, but in board they may ask, they may not ask, right? So we are trying those conditional identity के थोड़े बहुत sum. एक तो मैं बना के देती हूँ आपको. If cos theta minus sin theta is root 2 sin theta, prove that cos theta plus sin theta is root 2 cos theta. How to do it? There are two ways. Direct use of given data in LHS or RHS if possible. Here direct use of given data is not possible. Right? Right? So we have to start simplifying given data. Sometime you will get something very simple. जैसे वो आपको सिखाया था 10a plus cot a is 2. Then prove that 10 raised to 4a plus cot raised to 4 is 2. So in that we start with both sides of given data, go on simplifying till you get 10a is 1 and cot a is 1. That is the most simplified form of your given data. Direct given data was not ready to help you, but modified given data now is ready to help you. You put value of 10 and cot and answer will be 2. And मैंने आपको सिखाया था even sin plus cosec is 2 या cos plus sec is 2. Then your sin raised to any power plus cosec raised to any power will be always 2. So that was also conditional identity, right? This is also conditional identity. Look here. I start with both sides of given data. Cos minus sin is root 2 sin. So cos is root 2 sin plus sin. This minus sign goes this side plus. So it is root 2 plus 1 sin. Okay. I got my cos theta as root 2 plus 1 sin. Now you multiplied both sides with root 2 minus 1. It is nothing but I am rationalizing root 2 plus 1. Okay. So it is root 2 minus 1 into cos theta is equal to 2 minus 1 into sin theta. See, in previous case when we start with both sides of given data, we got something very simple. So something very simple has been used for LHS of you have to prove data and come to RHS. Here when we start with both sides of given data, automatically you are going to get both sides of to prove data. So nothing is left to prove. आ गया देखो. minus cos will be taken on that side. It is cos plus sin is root 2 cos theta. So I start with both sides of given data and come to both sides of to prove data. So now I need not to prove anything, right? There are three types of sum in conditional identity. Direct use of given data, using modified form of given data, and sometimes start with both sides of given data and come to both sides of to prove data. So no use of, total use of given data and got the to prove data. So first method is direct use of given data. I am giving you one sum where I am using direct given data. Direct use of given data. Second is using modified form of given data. Form of given data. That we have done many sum. That we have done. This part is this type of sums we have done. अभी मैंने रिकॉल करवाया 10 plus cot is 2, prove that 10 raised to any power plus cot raised to any power is 2. In that we were using this method. Here I have used, in this 19 sum, I have used the third method. Start with both sides of given data. Both sides of given data. And come to, go on simplifying till you get both sides of to prove data. And come to both sides of to prove data. Clear? So third type of sum also we have done. Second and third type is clear. First type is direct use of given data. Suppose a cos theta plus b sin theta is c. Suppose you are given if a cos theta plus b sin theta is c. Prove that something like this, a square minus c square upon b square minus c square is something. A square plus b square, a square plus b square minus c square upon a square plus b square plus c square is suppose sec square theta or cos x square theta. Such type of sum is asked. So here direct use of given data you can apply in your LHS. You start with LHS a square plus b square minus c square upon a square plus b square plus c square. In place of c square you put a cos theta plus b sin theta whole square. Go on simplifying till you get RHS of your to prove data. So this type of sum where you are using direct use of given data. This is the sum based on direct use of given data. Given data को पूछने का क्या आती है खंडाला? हाँ? वो बोलेंगे हाँ चलो. Take it directly in any one side of your to prove data. Make use of given data directly in any one side of to prove data and get the another side. That is called first method. Second method, your given data is very complicated, not ready to help you. Then simplified it and then use it. That is second method. And when you start simplifying given data and automatically just below you will get both sides of to prove data, nothing is left to prove. Okay. So there are three type of conditional identity. Okay. This sum later on I will do it. First let me complete. Let me rub out this. Let me start this sum now. See, cot A is 12 by 16. So it is 3 by 4. So tan A is 4 by 3. Clear? So now from direct triplet, without any method, you know about the triplet. This is 4, this is 3, this is 5. K लिख दो चलो ना 4K 3k, 5k. Triplet. So what is your sin A? Sin A is 4 by 5 and cos A is adjacent. So 3 by 5. Put the value here. 4 by 5 plus 3 by 5 upon 4 by 5 minus 3 by 5. So my answer is 7 by 5 upon 1 by 5. So my answer is 7. Clear? How to get the values of remaining function, or how to get value of some expression when value of one function is given. Okay. 20. Let us start with that conditional identity का first type. If sec theta plus tan theta is P, prove that P square minus 1 upon P square plus 1 is sec theta. This was asked in CBSE 2004. Now, can you say this is first type of sum? Because your given data is a value of P and your to prove data LHS contain P. So I can directly use my given data. I start with LHS. I am using my given data. For P I can put sec plus tan. So it is a direct use of given data, okay? So there are three different ways of proving conditional identity. Direct use of given data. Given data is not ready to help me. Then you go beside the sum. Start both sides of given data. Go on simplifying. There are two possibilities. Ya to you will get something very simple. Then use that something very simple in any one side of to prove data and get the another side. Or if you will get both sides of to prove data, then matter is that. You need not to do anything, any more thing. You got the answer. Okay? So when you start with both sides of given data and simplifying it, there are two possibilities. Ya to you will get something very simple, ya to you will get both sides of to prove data. If you get both sides of to prove data, sum is over. If you get something very simple, then you use that something very simple for proving your to prove data. Okay? Are you clear? So each type of one sum I have shown you. Open it. Sec square plus tan square plus 2 sec theta into tan theta minus 1 upon sec square plus tan square minus 2 sec theta into tan theta plus 1. Clear? Here you will get sec square minus 1 is tan square. So it is 2 tan square plus 2 sec into tan. Okay? And here you take tan square plus 1 is sec square. So it is 2 sec square theta minus 2 sec theta into tan theta. But I want my answer is sin theta. What to do now? 2 tan theta common. अंदर आएगा tan plus sec. नीचे आएगा 2 sec theta कॉमन. अंदर क्या आएगा sec minus tan. Okay, but I want sin, so here I have done some mistake. So here is plus. Got it? What mistake I have done? I have taken sec tan square plus 1 is sec square. So 2 sec square plus 2 sec into tan. It was not minus. Minus तो ऊपर है इधर. So here sec square minus 1. Sec square minus 1 is tan square. So tan square and tan square 2 tan square plus 2 sec into tan. And here tan square plus 1 is sec square. So sec square plus sec square 2 sec square plus 2 sec. So this cancel. This cancel. And what do you mean by tan by sec? Tan is sin by cos. In the beginning we have done this type of sum. Express this in terms of tan. Express every relation, every trigonometric ratio in terms of cot. That type of sum we have done. 1 upon sec is cos. So my answer is sin. and that is RHS. I start with LHS of my two proof data and come to RHS of my two proof data just by using given data, because given data. Clear? So are you clear with all type of sums or not? Clear? Okay? Polynomial we are going to start. In first semester you are in your syllabus polynomial, trigonometry, real number, right? So 6 topics are in your first semester. So first we complete those 6 topics, and then for second semester there are 9 topics. So we are going to do those 9 topics.